This video will explore the process of creating a full-stack web application using React, Node.js, Express, and PostgreSQL. We will discuss the key components of each technology stack and how they interact to create a cohesive application. Building a full-stack web application involves developing both the front-end and back-end components of the application. The front-end is responsible for the user interface and interaction, while the back-end handles data processing, storage, and retrieval. By combining React for the front-end, Node.js and Express for the back-end, and PostgreSQL for database, we can create a powerful and scalable web application. Our project will have a simple folder structure. We'll have two folders, back-end and front-end. The back-end folder contains the back-end code and the Docker file. The front-end folder contains the front-end code and its Docker file. We will also have docker compose.yml. It defines the Docker services for running the application. Break down the back-end code line by line. We start by importing necessary libraries and modules required for our backend application. We need Express. This library helps us in creating our server and defining routes. We need pool from PG that enables us to interact with our PostgreSQL database. We need body parser, the middleware which helps in parsing the incoming request bodies. We need CORS, the middleware which allows cross-origin resource sharing, which is important when dealing with requests from different domain. We create an instance of Express to represent our web application. We then use the CORS middleware to allow requests from a specific origin. This is essential for enabling communication between our frontend and backend, especially when they are hosted on different domains. We then set up a connection pool to our PostgreSQL database using the pool constructor provided by PG library. Configuration options such as user, host, database name, password, and port are provided. These can be either environment variables or hard-coded fallback values. We have an immediately invoked function that asynchronously initializes the database and inserts seed data. This ensures that our database setup, including table creation and initial data insertion, occurs when the server starts. Let's delve deeper into the code inside the IFI, which is our data seeding portion. We first create a new instance of the database connection pool constructor from Postgres. This pool manages multiple client connection to the PostgreSQL database. We use await pool.query to execute a SQL query that creates a table called names if it doesn't already exist. We define an array, initial names, containing names to be inserted into the names table as seed data. We create an array of SQL insert queries for each name in initial names. Using promise.all, we execute all insert queries concurrently to optimize performance. We then wrap the database initialization logic in a try-catch block to handle any potential errors. Finally, we close the connection pool using pool.end to release resources when the initialization process is complete. Now, let's write the first API, get/API/names. This endpoint handles get request to retrieve all names from the names table. We use pool.query to execute a SQL select query to fetch all rows from the names table. If successful, the retrieved rows are sent back as a JSON response. If an error occurs during query execution, we respond with a 500 internal server error along with the error message. The second endpoint handles post requests to add a new name to the names table. It expects the name to be added in the request body. We use pool.query to execute a parameterized SQL insert query to insert the name into the names table. If successful, the newly inserted row is sent back as a JSON response. If an error occurs during query execution, we respond with a 500 internal server error along with the error message. Now, let's write the Docker file for the backend. The Docker file begins by selecting the Node.js version 16 as base image to build upon, ensuring compatibility with Node.js applications. It then sets the working directory inside the container to /user/src/ app. A common convention of storing application code in Node.js project. The Docker file copies the package.json and package.lock.json files from the host machine into the container's working directory, facilitating dependency installation. Next, it runs npm install to install the Node.js dependencies specified in package.json. Following that, it copies the entire application code from the host machine to the container's working directory. The Docker file exposes port 3001, indicating the container will listen on this port at runtime. Lastly, it defines the default command to start the application, typically using npm start to launch the Node.js server. The Docker file provides a streamlined process of building a Docker container for a Node.js application, enabling developers to package and deploy their application with ease. Now, let's quickly go through the front-end code. In the app.js file, the React's main application component is defined. It utilizes React hooks, specifically useState and useEffect, to manage and handle side effects. The useEffect hook is used to fetch the list of names from backend API upon component mounting. Similarly, the handleAddName function sends a post request to the backend API to add a new name to the list. The component renders a form for adding names and a list displaying existing names, both encapsulated in separate components. The addName form.js file contains a functional component responsible for rendering a form to add new names. It manages local state using the useState hook and submits the entered name to the parent component upon form submission. Finally, the namelist.js file defines a functional component that receives a list of names as a prop and renders them within a list group component from the React Bootstrap library. Each name is displayed as a list group.item. Together, this component compose a simple React application for managing a list of names. Now, let's take a look at the Docker file of the front-end code. It will be very much similar to the previous Docker file in the backend code. The difference will be that this Docker file exposes port 3000 using the expose directive, while the previous one exposed port 3001. Now, let's explain the Docker compose file, which defines three services. Postgres. This service uses the official PostgreSQL image. It specifies environment variables for setting up the PostgreSQL database, such as username, password, database name. Port 5432 is exposed for accessing the PostgreSQL instance. Backend. This service builds the backend application using the Docker file located in the backend directory. It maps port 3001 of the container to the port 3001 of the host machine, allowing access to the backend application. It also specifies as volume mapping to synchronizes the front-end code to synchronize the backend code between the host and the container. Environment variables are set to configure the backend to connect to the PostgreSQL database. Similar to the backend service, the front-end service also builds the front-end application using the Docker file located in the front-end directory. It maps port 3000 of the container to the port 3000 of the host machine, enabling access to the front-end application. Volume mapping is used to synchronize the front-end code between the host and the container. These services are orchestrated by Docker Compose, ensuring that the dependencies between the services are properly managed. For example, the backend service depends on Postgres service, ensuring that PostgreSQL database is running before the backend application starts. Now that we have our application set up, to start the application, navigate to the project directory in your terminal and run the following command: docker compose up. This command instructs Docker Compose to build the necessary images and start the defined services. You will see the output from each service, including logs from PostgreSQL, backend and frontend. Accessing the application is simple once the services are up and running. You can access the application in your web browser by going to localhost 3000 to view the application. With the application running, you can interact with it just as you would in a development environment. Add new names using the form provided on the front end, and you will see them appear in the list of names displayed on the page. For stopping the services, all you need to do is to press Ctrl C in the terminal where Docker Compose is running. Alternatively, you can run the following command: docker compose down. This command stops and removes the container for the services defined in the docker compose.yml file. Overall, this video serves as a practical guide for developers looking to containerize and deploying their full stack web application using Docker Compose. Thank you for joining with us today. If you like this video, please subscribe, like and share with your friends. And as always, happy coding.